All right, I want to walk through a couple examples dealing with normal and uniform distributions, specifically some Excel skills related to these particular distribution patterns. So number one, we're given the manager of a local soft drink bottling company believes that a new beverage dispensing machine is set to dispense 7 ounces. In fact, dispenses an amount X random anywhere between 6.5 and 7.5 inclusive. Suppose X as a uniform probability distribution. Find the mean and standard deviation for this distribution. Okay, so I'm going to go over to the formula chart. Now for uniform distributions, it's really just a set of formulas, and I'll kind of show you some, how we might go about interpreting these for Excel. So let me kind of go back. As far as mean goes, I want to just add up the first and last number and divide that by 2. Okay, so in Excel, I would just find a spot, type equals, and I want to add the first and last number together. So parentheses 6.5 plus 7.5, close that, and then divide by 2, which means the mean happens to be 7, which is nice because it's exactly what it says. And then I want the standard deviation, so that's a square root, parentheses, and then I want inside the fraction here, so we're going to do another parentheses, b minus a, so 7.5 minus 6.5, close that, and I want to square that, so square 2, divide, and 12, and then hit enter, and so I get a standard deviation of 0.288 for that answer. All right, that brings me to the second question for number 1 is what is the probability that a randomly selected bottle the machine will dispense at least 6.75 ounces. So what I want to do is I want to take a look at the picture of this distribution. Uniform distributions look like a rectangle, so it should look like this. Okay, so it looks like a rectangle with the lower end at 6.5, the upper end at 7.5. The height is take the difference, the range, and divide that by 1. So it happens to be 7.5 minus 6.5 is 1. So that's why the height here is 1. And so if I want the probability that a randomly selected bottle is less than 6.75, then I'm finding the area of a rectangle with those dimensions. So you have to think, I'm kind of estimating where this line is, but I want the area of this part right here. So it's got a width of, let's see, 6.75 minus 6.5. So it's got a width of 0.25, and it's got a height of 1. And so I just want to find the area of a rectangle. So that would be the length times the width. And so the probability that an observation is less than 6.75 would be 0.25 or 25% of the time. All right, number 2, we're going to switch distributions to talk about the normal. So we have a professor that's got grades on a final exam, normally distributed. It's a mean of 64 and a standard deviation 11. And if the passing grade is 54, what percent of the class will fail? So let me run to the formula chart here. Okay, so in this case, I want to calculate the probability of a certain observation happening, and that's going to be either the norm PDF or the norm CDF. The difference between the two, the PDF function for all stat distributions are a single observation. A CDF is that observation or less than it. So all CDFs are measured in terms of less than. So going back to the question, if passing is 54, what percent will fail? So anything smaller than 54 would be considered failing, right? So let me set up the norm CDF on this. Okay, so I'm going to do equals norm. Now notice as I start typing, norm distribution pops up. Double click on that. It wants to know the observation, which in this case is 54. It also wants to know what the mean of the distribution is, so 64, and the standard deviation being 11. And then lastly, I want to type in the word true or just click the word true. and that'll identify that I'm doing the cumulative distribution. So that means 18% is less than 54, so 18% of the class would fail. Let me kind of show you one other way to do the exact same question, but using z-scores. What I just showed you is actually sufficient for most problems, but occasionally we need to convert it to a z-score, and that's actually not too bad to do. So z-score is first figure out what the related z-score is. So that's this observed minus expected divided by standard deviation. So for our benefit, it's equals parentheses. Observed is a 54 minus the expected, which is 64, and then divide that by the standard deviation, which is 11. So I have a z-score of negative 0.9, which means 54 is negative 0.9 standard deviations below the mean. And then I'm going to go right back to do norm distribution again. But this time I'll do the exact same problem in terms of the z-score and a standard normal curve. So a standard normal curve has a mean of 0 and a standard deviation of 1. Given that observation, oops, and I need to type the word true. And we should get the exact same percent. So we do. So you can convert to z-scores and then set up your norm CDF using standard normal parameters, or you can set up your norm CDF using the actual mean and standard deviation of the original observation. All right, next question. What percent of the class scored between 50 and 70? Okay, so in this case, one thing I have to recognize in Excel is that the CDF function always measures in terms of less than. So if I want between two values, then I'm going to calculate two CDF functions, one for 50 and one for 70, and then I'm going to subtract the two because the overlap will give me the number between 50 and 70. So let me set that up. So norm distribution, let's start off with 50, comma 54, comma 11, comma true, and then I'll do the same thing, but this time I'll do it in terms of 70. Oops, sorry, 64, comma true. I just want to double check that I set that up right. Oh, okay. Let me try that again. I actually typed 54 in instead of 64, so that one is wrong. I apologize for that. Okay, so 50, comma 64, comma 11, comma true. Okay, and then to find the percent actually between those two values, then I want to subtract. So in other words, what this is saying is 50%, and sorry, 10% of my data falls less than 50, 70% of my data falls less than 70. So to get between 50 and 70, that's where I'm subtracting the two numbers. So big number minus the small. And so I get exactly 60% between those two numbers. And I'll go back and highlight this. And then the last feature I want to talk about for this question is an inverse norm. So if Professor Rogers only wants 85% of the class to pass, what should the passing grade be? Now, keep in mind, we measure things in terms of less than. So I don't want the top 85%, I want the bottom 85%, which means I only want 15% to fail. So when I set up my norm inverse, so notice norm inverse shows up, I'm going to set the probability below a certain value at 0.15, mean of 64, standard deviation 11, and true. Where did I? Oops, sorry. Not true. that's with norm CDF. Okay, so just probability, the mean, and the standard deviation. And so if the passing test grade is set at 52.6, then 85% of the class would be above that point and would pass the test. Okay, the very last thing is just understanding the terminology here of finding a critical value for z of 0.05. Let me kick that over to Excel. Okay, so what a critical value means is when we make an observation, that observation is either something we would expect to see, or it's really close to something we'd expect, but there's going to be a number that surprises us, that allows us to go, wonder why that happened. Just a real-world context, if I take my cat to the vet, and my wife and I expect to pay $100, and the vet comes back and says it's going to cost $500, I'm going to stop and want to look at a little more detail as to why. I expected $100, and now I'm being asked to pay $500. But if I expect to pay $100, and the vet says it's going to cost $120, I'm not so upset about that. I'll just hand the money, or the extra $20 without even thinking about it. So somewhere between $120 and $500, there's a magic number that $1 more, all of a sudden I'm really interested in the details, and $1 less, it's not as important to me, right? So that's what a critical value reference is. A critical value means what z-score would I care 1 point bigger than would be all of a sudden like, oh, I want to know more about my data, and 1 point less, I'm not that as interested in. So this 0.05 refers to a percentage. So we're saying that the z-score related to the top 5%, and that means we're looking at an inverse norm. So norm inverse. So the top 5 would mean, remember this is all measured in terms of less than, means I'm looking at the bottom 95% here, so 0.95 in a standard normal curve. So mean of 0, standard deviation of 1. And so any z-score that I calculate that's bigger than 1.64, I know is already less likely, is only going to happen 5% of the time or less. So it just gives me a way to say, oh, that my observation is shocking or not. But anyways, so if you're asked to find the critical value, then that's an inverse norm concept.